Hello students, welcome to FIZIX Coach. I'm back with the first chapter of your class 8th, that is force. Now, I'm calling it first chapter because it is the first chapter or the first unit of physics. Although in your class 8th you study physics, chemistry and bio in one combination under the name science, but we have classified it into physics, chemistry and biology. So this is the first chapter of physics. Now, in this chapter, what all things we'll be studying is, we'll be studying the definition of force, we'll understand what is force, then we'll be understanding effects of force. So what are the effects of force? If a force is applied on any object or anything, then what all things can happen? What could be the effects of force? The next would be balanced forces and unbalanced forces. We'll be studying what is the difference between them and what are the characteristics of balanced and unbalanced forces. The next topic would be types of forces. So then the division of the forces would be done. Its classification we'll be studying. We'll study how many types of forces are there and how do those forces work and how they are differentiated also. Then the spring balance, that is the method for measuring one of the forces that we call as weight. And after that, the final and the last topic of this chapter for your class 8th is the difference between the mass and weight. So before beginning, as I always tell you, class 8th is very important. Why? Because the class 8th forms the basis of your syllabus, of your courses, of your future classes. Like the most of the topics you'll be studying in class 8, they'll be repeated in your class 9th, 10th and even in 11th and 12th with the same names or some different names or with some additional concepts. So it's like a ladder, right? And this is the first step onto the ladder for understanding the basic concepts. If your basic concepts are strong, then if your foundation is strong, then your future subjects like physics, chemistry and biology, they'll become stronger, right? And you won't face any problem in cracking or getting success in the exams, Olympiads or competitions which you'll be facing in future. So let us start with force. Let us understand what is force. So how will we define force? We'll be defining force on the basis of effects of it. See, the definition says force is a push or pull which changes or tends to change the state of rest or motion of a object, right? Now we have used the term uniform motion here. So I'll make you understand what is uniform motion, but first let us understand the definition. So the definition says force is a push or pull which may change or tend to change the state of motion. That is, if something is at rest, then it will, if you'll push it, it will start moving. Or if you'll pull it, then also it will start moving. And if something is at already in motion, then you can just apply force in the opposite direction and stop it, obviously. And you can also push it and increase its speed, right? So that is the change in state of rest and motion. Then it can also change the direction and shape. Now let us take an example. If you're playing football and two players are there who are running after the ball, and one player wants to take it in a particular direction, right? But the another player comes and he applies force by kicking on it and he changes the direction of the ball. So By applying force, the direction can also be changed. I've just taken an example of a football. There could be many examples for it. The last one, that is shape. Forces also change the shape of an object. So let us take an example of it. Forces, if you apply force on a balloon, right, which has air inside it, a inflated balloon, if you press it, what will happen? Its shape changes, right? Similarly, for understanding, you can also take an example of a spring. If there is a spring and you stretch it, by stretching I means if you're pulling it. By pulling I mean I'm applying some force on it, right? So if I stretch up a spring, obviously you know that its shape would change, it elongates, right? So I'm sure the definition of force is clear to you in your mind. That is, force is a push or pull which changes the state of rest or motion of a body, or the direction, or the shape, right? Now, one thing you need to note it down. Whenever in your exam the question is asked from you for defining any quantity, like the question comes and like it says define force, right? So whenever you are defining force or any quantity, it should have three things. The definition or your answer should have three things. One is the statement which defines it. Second is its mathematical representation or its mathematical formula, right? That would be how will you calculate the value of that particular force. What is the formula for that? And third very important thing is its SI unit, that is standard international unit of that particular quantity. That makes the answer complete, which has all the three parts in it, right? So here we have defined it. This is the statement. Now mathematically. So mathematically you can see I've mentioned the force formula for force is F equals to ma, right? This force is equal to ma is actually F is equal to m into a, where m is what? Where m is mass and a is acceleration, right? Now, what is mass? Mass, we all know, mass is a quantity which is for an object which is having its mass. Mass is said to be because of its content, right? So mass is there because of the content of the object, and SI unit of mass is what? SI unit of mass is kg, right? And acceleration, this we need to understand what is acceleration. Acceleration is, let us understand with an example. In your cars and bikes you have an accelerator, right? So what is the use of that accelerator? By accelerator we increase the speed, and we can also decrease the speed using the accelerator, yes or no, right? Yes. So by accelerator, by pressing it, you can increase the speed. By releasing it, you can decrease the speed of an object or a car or something, right? So let us take an example. If you have a object or a car or a ball, whatever you can make it, if this object is moving with a speed u here is representing the initial speed, and someone pushes it from back, it applies a force F on it. What will happen if you push something which is moving in the same direction? Its speed will increase. So it reaches this point, its speed becomes v, right? And the time taken for this change in speed is t, that is time. Yes? So when you apply force, then the speed changes. It might, in this case it is increasing, right? If I apply force from the opposite direction, the speed will decrease also, right? So basically by applying force, we are either increasing the speed or decreasing the speed. Now it depends for how much time the force is being applied, right? If we apply force and the speed increases, we say the object is accelerating. Now what does this mean? This means the speed of object is changing in some particular time, that is t, right? And this is what acceleration is. If you understand, acceleration is change in speed per unit time, right? What is acceleration? Acceleration is change in speed per unit time. Now, how will you calculate change? You'll subtract v, that is the final speed, from initial speed v minus u, and per unit time means you will divide it by t. So this is acceleration basically. Acceleration is change in speed per unit time, or rate of change of speed also you can call it, right? Now, by multiplying mass and acceleration, we can get the value of force. All right. So what you can write this formula as what? You can write this formula as also as F equals to ma, which can also be written as m multiplied by v minus u upon t. That is the basically the value of acceleration I have put it here, right? So this is the formula for force. This you should always remember and mention, very useful formula. All right. So as I told you, three things: statement, then the formula, and then you should always mention the SI unit. So the SI unit of force is Newton, right? It is represented by capital N, right? And why it is Newton? Because it's the name has been kept on the name of Sir Isaac Newton, a great physicist. And if we convert it into CGS system, that is centimeter, gram and second system, then its unit is called dyne, right? So it is a smaller unit. So 1 Newton, you can remember this also, 1 Newton is equal to 10 power 5 dyne. This is how you can, it can be helpful for you in converting the values, right? So this completes the definition. Now you know what is force, how to calculate force using the formula, you know what is acceleration, and you know its SI unit and its CGS units, that is Newton, and CGS unit is dyne. All right. So this is the complete thing about force, definition of force. Now, as I told you in the beginning, I will explain you the meaning of word uniform motion, right? Now see, when an object is changing its position, we call that the object is in motion, correct? But if the acceleration of an object is 0, if acceleration of an object is 0, then the object is said to be in uniform motion. Now what does this mean? Acceleration can be 0 when? Acceleration can be 0 when v is equal to u. V is equal to u. Then acceleration will be 0. That is, what does that mean? It means that initial speed and final speed of an object is same. Right? It's not changing. That is why acceleration is 0. And in which case the speed could be same? When there is no force applied on it. Right? So if some object is moving and there is no force applied on it, and in that case if you apply an external force on it, then the object's speed would increase or decrease. Right? Like if some object is at rest, then obviously it is at rest, so its v is also 0 and its u is also 0. So acceleration is 0, it is not moving. And in that case, if you apply force, then the object starts to move. Got it? So that is about uniform motion. So now the definition is complete. We have understood what is force and mathematical part, units, what is uniform motion, what is acceleration. Although you'll be studying acceleration and the derivation of this formula in your class 9th. Right? But if this concept of yours is clear, then in your class 9th, it would be very easy for you to understand the Newton's laws of motion. Right? So that's why I say the things are connected. All right. So next, let us move on to the effects of forces. Right? So in the definition only, we have already discussed what are the effects of forces. 3 basic effects of forces: the change in state of rest or motion, the change in direction, and the change in shape. So there are various examples. See, this man is trying to push this table. So he is applying a force on this table, and if the table starts moving, then what is there? There is a change in speed, obviously, right? So, but one condition is there that no other force should be applied on it, right? If no other force is acting on it and he applies forces, then the object will start moving. Here you can see this small little girl, she kicks the ball and she can change the direction of the ball while kicking it, right? Similarly, change the direction. The example could be a ball, right? Whenever a bowler throws the ball towards the batsman, it comes to him straight, and the batsman makes a shot and changes its direction. Now, the ball can move in any direction according to the shot, right? And the third one is the force can change the shape. You can see the change in shape if you're pressing this clay, right? The clay changes its shape. So these are the effects of forces. This is also important. It is many times asked in the exams, and might be it should be asked in your school exams also, that what are the effects of forces. So these 3 effects you can mention. Let us do some numericals based on this. We have learned the formula right now for the force. So see, what does this question say? It says, calculate the force required to produce an acceleration of 5 meter per second square in a body of 2.4 kg, right? So see, there is a method of solving the numericals. Follow these steps, you will never get your answer wrong, right? First of all, what you have to do is, for the solution, you write what is given. Right? What is given? It says the acceleration is given. Say acceleration A, it is given 5 meter per second square. And then mass of the object, M, is given 2.4 kg. Right? What it is asking? It is asking to calculate the force. So to find is what? You have to find the force. Right? When you have written this, we know we need to find the force. And formula used? What formula is there for force? Force is equal to mass multiplied by acceleration. Now you can always write calculation and put the values in the formula. F is equal to mass is given 2.4 multiplied by acceleration is given 5. Right? Now what will be the answer? (12.1). What would be the unit? Newton. Yes? So the answer to this question, F, is 12 Newton. You should always make a box outside the answer and mention like this, answer. Right? This is the proper way to solve a numerical. You will never get it wrong. Alright? Is it clear to everyone? Let's solve one more. Okay, so again we'll write given. It says a force acts for 0.2 seconds on a body. So what is the value of time here? Time is given 0.2 seconds. Then it says on a body of mass of body is also given 2.5 kg. And it says it was initially at rest. Initially at rest means the initial speed u was 0 because it was said to be at rest. Right? The force then ceases to act and the body moves through 4 meters in the next 1 second. Right? Now what does it say? That the force stops and body moves through 4 meters in next 1 second. So see what is given. Now reading the question and interpreting it is also very important. It says 4 meters in 1 second. Right? That means it is the speed, the final speed is being given 4 meters per second. Yes or no? If some object is moving 4 meters in 1 second, that means its speed is 4 meters per second. Now, to calculate the magnitude of force, it wants us to find, what is to find? To find is force. Force equals to what? Now, we'll write the formula. Formula is force equals to ma. And here, because acceleration is not given, we'll have to use the formula for acceleration also, which says acceleration is v minus u upon t. Right? So first, now the calculation part. In calculation, first you will have to find a. So v is given 4, u is given 0 because the object was at rest. Time is given 0.2. So acceleration becomes 4 upon 0.2. Well, what can you write for this? See, this is, you can write it like this. I'll explain you properly. It is 2 upon 10, so 10 will go up, and it is 2. So acceleration comes out to be 20 meter per second square. Right? And now this value has to be put in formula for force, because finally we have to calculate force. So F is equal to ma. What is m given here is 2.5 multiplied by 20. So it will be 25 multiplied by 2. Yes? So it is 50. And what will be the unit? Newton. So you can now write F equals to 50 Newton, and you can make a box and write answer here. Right? So this is the way of solving the questions. Right? You want to do one more? Alright, let's go for one more. Say, a ball, again we'll write given. It says a ball of mass 20 grams is initially moving with velocity. So m is given 20 grams. Then velocity is given, is initially moving. So u is given 100 meter per second. On applying a constant force on the ball for 5 seconds, time is given 0.5 seconds. It acquires the velocity of 150 meters. So v is also given 150 meter per second. Calculate the following. It wants us to find first acceleration. So it wants us to find acceleration, and it wants us to find force. Right? So again the formula used, same. F equals to mass into acceleration, and acceleration equals to v minus u upon t. So just put in the values and solve this question, right? This is homework for you. We'll continue with the chapter in the lecture number 2 and study the further topics. Thank you so much for today. Hope you would have understood the concepts very clearly. Thank you.